Okay, so here we're just going to work through a few equations involving fractions because it can seem like they're quite different than maybe if we just have equations involving whole number or integer coefficients and constants. And so the way that we typically deal with this is what we call clearing the denominator, which we did in the lecture video. We only did one example there. So let's take a look. How does clearing the denominator look in these different types of problems involving fractions? So let's start with A here. So we're asked to solve for the variable that makes this equation true, where some number plus 2 and then divided by 5 is equal to some number minus 1 divided by 3. Okay, so we don't like that there's fractions, right? The way I recommend going about this, and again, this is not the only way. You can Google probably 15 different ways to solve this problem. But this is the way I've found over how many years of teaching that this works the best, and it always works. So to clear the denominator, you need to find that least common denominator, or least common multiple of the denominators. And what do we have? We have 5 and 3. Now, one way to just find a common denominator, not the least, is to just multiply the two, which here is 15. But we know this is actually the least because 5 and 3 are both what we call prime, meaning they don't have any other factors besides 1 in itself. So there's no multiple of 3 or 5 that happens sooner than 15. So this is what we use to clear using the balance principle. So we multiply both sides by 15 over 1. Again, notice how I'm using brackets here. Big old brackets because it's the entire side being multiplied by 15, not just one number. So then what does that look like? Well, 15 over 1 times something over 5. Now this might seem confusing because we have, so this might seem confusing because we have this x over 2 up top, but really it's no different than if this were like 15 over 1 times 3 over 5. Right? We're still going to cancel a factor of 5. So let's do that here. This is not the actual problem, right? I was just highlighting that this is the same. So we're going to cancel a factor of 5 because 15 is really 5 times 3, which is the reason that we chose it. So these 5's cancel and we're really just left with 3 times x plus 2 on the left. And then the same thing will happen over here. 15 is 5 times 3, so the 3's will cancel and we'll be left with a 5 times what was over here, x minus 1 in the top. So we're seeing how this was left over. The bottom reduces to 1 because when we cancel everything in the bottom like we did here and here, the denominator just becomes 1, so we don't need to write it. And that's why we're doing that. And so now it just becomes a distribution problem. Positive 3 times positive x is positive 3x. Positive 3 times positive 2 is positive 6. Positive 5 and positive x give me a 5x. And positive 5 and negative 1 give me a negative 5. And then from here, it's isolate the variable like we've done before. So we'll subtract 3x from both sides. So the 3x's cancel. I know I'm going quickly here, but this is because at this point we've done problems like this style before. So 5x minus 3x gives me a 2x. Everything else stays the same. Positive 6 minus 5. All right, so it's these guys. And then we'll add 5 to both sides to cancel out this minus 5. We'll get 11 equals 2x. And then we'll multiply both sides by 1/2 to drive that coefficient to 1, and we'll be left with x equals 11 over 2, or 5 1/2. Okay, so started with the LCD, multiplied both sides by that number in order to get the denominators to cancel like they did here. So let's do another one. Let's do part B. And again, make sure you're rewinding, going back through, listening to the rationale if you need to. So 4x plus 3 all over 20 equals 1 plus x minus 1 over 5. Is that right? Yes. Okay. Sorry for getting dizzy there. So, solve for x. So here, again, identifying all the fractions, we have a denominator here. We don't have one here, right? That's just a denominator of 1. And here we have a denominator of 5. So what's the LCD of 5 and 20? Well, it turns out 20 is actually a multiple of 5, so it is 20. So if I multiply both sides by 20, we'll get a nice reduction in the fractions. We'll clear the denominators by doing this. So we take this 20, multiply both sides by 20 over 1. Look at those huge brackets I'm using to do the whole side, right? Otherwise, it's not really multiplying both sides by 20 and it will lose equality. So here the 20s cancel, which is nice. And then we're left just with 4x plus 3 over 1. So we'll just rewrite that as just 4x plus 3. Anything over 1 is just itself. And then here we have this being split through addition. So we have to distribute this 20 over 1 in to the, I missed the 1 here. So this 20 times 1, which gives me just 20, plus, and then 20 times x minus 1 over 5. Now this might be a little bit much going on, so let me bring this out to the side so you can see what will happen. So if I have x minus 1 over 5, you notice how I'm writing those brackets in there, times 20 over 1, what's going to happen is this 5 will cancel because 20 is really 5 times 4. So we can cancel this common factor here before continuing and saying, all right, well now I have in the top 4 and x minus 1, and in the bottom I just have 1. So this really just becomes 4 times x minus 1. And so we write that in where this product would have gone. Okay, so this was just this right-hand multiplication here. So now this looks like a kind of typical, a more typical linear equation where we just need to distribute, collect terms, and go from there. So 4x plus 3 on the left is 20 plus 4 times x minus 1. Distribute. Everything else stays the same. Positive 4 times x is plus 4x. Positive 4 times a negative 1 is a minus 4. And then from here, combining like terms, 20 and minus 4 leave us with a 16 positive. So we've ungrouped. Now we gather the variable terms to one side. So we look at 4x and 4x. Doesn't matter which one we move. You might see what's going to happen already here. Subtract 4x from both sides. And what happens? All these x terms cancel out and we get 3 equals 16. Which this is one of those special situations where we have a contradiction. Right? So this is what we call a never true equation for any value of x. Okay, so this statement of equality that we started with actually turned out to be false, but that doesn't change how we were able to solve it if there was a solution. You might even, in the software, you'd say something like DNE, which stands for does not exist, if you're doing an automatically graded problem. So these are kind of the AKAs when there's a contradiction like this. Okay, but that's not the main point of this problem. The main point of this problem was how we deal with the fractions. Okay, so you're still going to get to that endpoint through that process. All right, and the third problem here, let me just grab this. Okay, so here again we want to clear the denominators because we have fractions. So we go ahead and find the LCD of 7, 2, 14. These are the denominators I'm seeing, so it's got to be of 2, 7, and 14, which we know is 14. So this is going to be my kind of missile that blows up all the fractions. And again, how we use this technique is just multiplying both sides by 14 over 1. Now it's getting a little squished over there. But let's see what happens. So here is a place where we could easily get into trouble, so I'll go slowly. I'm going to do the right-hand side first. Okay, and show you that 14 over 1, if we distribute it in, okay, 14 over 1 times 3/7. I don't know what's going on with my pencil here. 3/7 y times 14 over 1 minus 1 times 14 over 1, which is just 14. Let me write that in like this, just so we see that there was distribution here. So what happens with this 3/7 y times 14 over 1? Well, the 14 is really 7 times 2, and we'll get these 7s to cancel. And so what are we left with? 3 times y times 2 in the top, all over 1. So we get 3 times 2 times y is 6y over 1. Minus, and then just negative 1 times 14 is just 14, negative 14. Okay, so that's the right-hand side. Now for the left-hand side, here, this is a little bit different, right? Because we have this coefficient, or this factor sitting out on the left-hand side, and it wants to be distributed, but we haven't done that yet. And that's actually okay. So the way to really see this is we have some A times B times C, right? Where here's my A, here's my B, here's my C. You can think of them as all each being one factor. And so what I'm just going to do is focus in on this A times B situation and see if I can get it to resolve. Okay, so let's do that. So what's 14 over 1 times 2/7? Well, we'll get a, let's write this out a little bit bigger. 14 over 1 times 2/7. We get to cancel a 7 and we're left with just 2 times 2, which is 4. All right, so we're left with 4 out front. That's what this A and B factors reduce to, times 1/2 y plus 3/14. Okay, so now we can go ahead and distribute again inside here. And so we'll see 4 times 1/2 y, 4 over 1 times 1/2 y, plus 4 over 1 times 3/14. Still have the same stuff on the right side. And so what's going to happen is this will cancel nicely, this 4 over 2. because this becomes 2 times 2, one of them cancels, and so we're left with this 2y. But over here, 4 times 3, I can cancel a factor of 2 if I make the 14 a 2 times 7, but it didn't destroy all the fractions. And that's okay, because we're still left with something a little bit better. So we got 2 times 3 in the top over 7, so that's 6/7 equals 6y minus 14. I'd say, Amalia, this didn't clear the denominators. That's all right. We can do it again and just multiply everything by the LCD, which we know now is just 7, because that's the only fraction left. So it's okay if you have to iterate a couple times or repeat the process. Not a huge deal, as long as everything's done correctly. So here again, LCD is 7. Multiply everything by 7 over 1. And then distribute this through again. 7 times 2y, 14y. 7 over 1 times 6 over 7. Again, the 7s are going to cancel here. We're just left with 6 over 1. And then here, we don't need to worry about any fractions, so we can just distribute the 7 into the bracket. So 7 times 6y is 42y. 7 times a negative 14 is what? 98, negative 98. And then we can solve from here. So collect the variable terms. So we'll subtract 14y from both sides. 42 minus 14 is 28. Minus 98 equals 6. Add 98. We get 28y equals 6 plus 98 is 104. And then we multiply both sides by 1/28. Get these to cancel, we get y equals 104 over 28. And now we can get some practice reducing. So this thing is divisible by 2 for sure. Might be divisible by 4, but you can try it in pieces if you'd like. So we see that they both end in an even number. So this is a clue to use a 2. So I know that 104 is really 2 times 52. And 14 is really, or 28 is really 2 times 14, so we can cancel factors of 2. And then we can do that again, right? Because 52 is really 2 times 26, and 14 is really 2 times 7. And so we get 2 times 26 over 2 times 7 equals y. These 2's cancel. Now 26 over 7, these no longer have any common factors, so this is as good as it gets. So that's some practice on reducing fractions. But with each of these, hopefully you're seeing how clearing the fractions by clearing the denominators using the LCD, it works every time, and at the very least it makes the situation better. Here we had a unique situation where this factor hadn't yet been distributed, so that makes it a little bit different than the other ones we've seen. But as long as we're following the order of operations and how distribution works, it will always work out.